I made a little bit of room because I'm probably going to walk about just a little bit, and I changed the title of my talk slightly from what you saw in the program. It's now called Transparent Anthropic Coordinate Transformation, or TACT. It's a model of consciousness and subjective experience, and so I had to come up with a title that had a nice little abbreviation because everybody does that. So that's why that's there. And this is not what I normally talk about. My daily 9 to 5, 6 days out of 7, I'd say, is about the process of how do you achieve whole brain emulation, so the study of neural circuits and things like that. And because that's what I usually do, I thought I would put in 3 slides in the beginning to tell you a little bit about that before I dive into this consciousness and subjective experience thing. So first of all, for anyone who doesn't know what is whole brain emulation and mind uploading, well, whole brain emulation is about reverse engineering the biological brain. So the same way that you would take apart a computer chip, you would look at it, you would trace out how the transistors connect, and you'd know something about transistors, and then you could try to come up with, oh, these are the functions that a chip can carry out. The same way you look inside the brain, you use electron microscopes, other kinds of microscopy, functional data recording of various kinds to get data from the brain, and then you attempt to reconstruct what's going on, apply various constraints to make sure that you're not making a lot of mistakes, that you're testing the validity of what you're doing, and ultimately to come up with pieces of technology that can work like parts of the brain and ultimately perhaps an entire brain. And right now we're mostly talking about really small brains, like the brains of fruit flies, things like that. But eventually you can imagine that you could create something that would be like the brain of a human. And in that case, you could call that a neural prosthesis for a patient. And even just the parts, various parts could be used to cure various deficits that one has, etc. But if you had an entire replacement brain in which to live, then you could perhaps carry on beyond your current body. And that's when you get to mind uploading. And this would give you all sorts of fantastical science fiction possibilities, like living in an environment that we're not currently suited for, like traveling into outer space or into virtual reality and what have you. Cognitive extensions. Imagine, for example, that if you ran your brain 100 times faster, suddenly things in the universe that are happening at the millisecond scale would become things that you're aware of and that are part of your experience, which would be totally different than what you're experiencing right now. So who knows? Where are we on that track to whole brain emulation right now in 2025? Well, as you can see over there, and I see that the videos are not running, but I guess they're just images right now. This is work that just came out a few days ago. It's the second complete, actually this is an even more complete version of the fruit fly brain that was scanned at a level where you can see every neuron, every synapse, even count the individual vesicles that carry neurotransmitters so that you could count them and get some idea of what the weights are of those synapses, so how strongly the neurons are connected to help you reconstruct. You see a few more different methods here. I'm not going to get into the details about that, but it's a matter of putting together this information about the structure of the brain with the function of the various components that are in the brain, for which atlases are being created, again, mostly in other animals at this time, not humans, but fruit flies, mice, etc. And that's going really well, because now we have these entire maps, for example, of the fruit fly brain, so you could try to do something with it. But right now, it's mostly just data sitting on a hard drive somewhere, collected from those experiments, but we don't have any models of working fruit fly brains. So this is the real challenge that's coming up now. When you have all of that data, what are you going to do with it? And the biggest problem is to try to come up with feasible ways of putting together the data in a way where you can validate that it actually works, that it's achieving your success criteria. The success criteria for whole brain emulation are that you end up with something that has the cognition, the cognitive ability of a brain, and in the case of a human mind, that it would also have experience, so the same kind of subjective experience that you're looking for. And this has, I'm trying to show here kind of diagrammatically what that's like, breaking it all apart into black boxes that are small enough to solve, where you understand the depth at which you have to investigate the problem, and more of that kind. And then, of course, there are issues of getting to the scale of a human brain. But right now, we don't even have a proof of concept in any brain, not even, say, the nematode, the little worm with just 302 neurons. But that's not what I'm talking about today. I'm talking about consciousness and subjective experience. So you just heard what I deal with on a daily basis, that kind of stuff, right? So why do I care about consciousness and subjective experience? It's actually very important to me because I was talking about success criteria a moment ago. How do you know that you've achieved the whole brain emulation that is doing what it's supposed to do? Again, experience is ultimately what you're trying to get out of it, what you're trying to preserve, the thing that really matters. So we need to have some understanding of what that is. Also, we don't really want to accidentally build something that behaves like a person, that seems like a person, but there's nobody home. So philosophical zombies, as Chalmers calls them. It's not clear if that's possible, even a philosophical zombie, but you don't want to have that. Also, in a world where we now have AI coming along, potentially AGI, whole brain emulations, and we already have in this world humans and animals and children and adults, and then you need to understand, where do you have to apply a caring for suffering and well-being? So what sorts of things can be conscious? So it's very important to understand what brings about consciousness, what are the requirements for consciousness, and how can there even be such a thing as subjective experience? The feeling that you're looking out from within, instead of that it's just all a machine working from the outside in. Now, if you look at theories of consciousness, so we spent a whole while doing a journal club, just going through every kind of paper with different perspectives. We tried to categorize them a bit, and some categories you can make, as you can see them on this side here. Some of them are all about that information needs to be integrated and accessible globally. Other theories are about what are the requirements to have the kind of conscious experience that we have. So various different requirements that are part of that. Then you have theories that focus on the importance of the biological, of the embodied, and others who are going from a completely different direction, taking consciousness as the origin, as the only thing that you know, and therefore fundamental, and perhaps everywhere. And so you've got lots of different categories, and I can't get into those because my time is running out fast. But I'm mostly focusing on these two here in integration and self-model areas, because those connect fairly well with the way that I'm looking at the brain already. And so this is the thing that we were trying to do in that journal club. We were trying to figure out which parts of these theories make sense to us based on what we know about the circuitry of the brain and how other things work in the brain, like vision, other kinds of cognition, parts that aren't consciousness itself, but that relate to it. And how do you go from that outside in, that functional physicalist perspective, towards something that can explain what the requirements are for a conscious brain, and then to try to make that leap, try to understand, how can there be a subjective experience? How can you suddenly go from, okay, we're explaining how all that cognition works, but why should there even be a feeling? Why should there be anything? So we want to explain the phenomenal structure, what that feeling is like as well from the bottom up. So we want to connect top down, bottom up. I talked about it like top down, bottom up, but also outside in or inside out is another good way to think about it. So that's what we really want to get to. And I want to put out a word of caution here, because one thing that is often said about subjective experience is that the only way to explore it is through self-report, through introspection. And that is true. But at the same time, we have to be very careful about what an experience is, or what we say, what we mean when we say, I've had this experience. Even when you're saying it to yourself, even if you're just sitting there, you're contemplating, you're being introspective, or you're meditating, you have something that comes up, you feel that you're aware of it. In a sense, you're reporting to yourself. As soon as you become aware and you can give it a name, you can sort of say, oh, I just noticed that vase over there, or something like that. You're reporting to yourself. So it's always a self-report. You have to distinguish self-reporting from what is actually going on. We can't necessarily say those are the same. One moment while I take a sip. Okay, so what is experience? Well, we're not getting everything that's around us, right? We're, like I already mentioned, right now the brains that we have only sample at a certain speed. So we're definitely not taking in everything that's happening, because a lot of things are way too fast for us. And because of the duration of our short-term memory and other aspects of how we live, there are also processes that happen way too slowly for us to really notice what's going on. Additionally, our senses don't take in everything. There are things that we don't know how to think about. For example, we can't just fall into solutions the way a quantum computer would solve things. So there are a lot of things that aren't necessarily part of how we experience reality. So it must be limited, that's for sure. Whatever we're getting about the world is limited. And there's also a temporal granularity that's involved in there. But you can consider that there's some kind of model, a virtual reality that's being built in our minds that we experience. It's not the real world, but it's a virtual representation of the world. And within that, there's a part of it that we become identified with, that we identify ourselves with. And it's not necessarily something automatic. It takes a little while during development to get there. And you become identified with that, or you identify yourself with it, because it's the part that's always with you wherever you're going as the circumstances around you change. It's also the part that you feel you have the most control over. You carry out actions, and so your body is kind of part of you. There are things in your mind that you can control, thoughts you can have, and you can go and remember something. These are all parts of you. You can, haul back experiences that you had 3 days ago, go through them again in your mind. So this is giving you the self-model part, the subset of the world model. And some of you, if you've ever read books, for example, by Thomas Metzinger, you might recognize this. This is kind of based on his self-model theory of how consciousness works. So it's like being in a full immersion total flight simulator, but there's a bit more to it. And I want to talk about this concept of transparency. There are a lot of things that in our conscious experience, we do not have access to. So we have here a world model, and within that, a self model. It's like this little virtual reality, this flight simulator being generated here. In that, there are a lot of things that pop into our world model and our self model where they're just there, but we don't know how they got there because the process of how they got there isn't part of what we can experience explicitly. So we don't know how our vision is creating an understanding of what objects are there. We don't understand those things about how our sensory input is being processed. Also, the internal representations of information, our memory. Why would something cause an association and then we pull back, oh, this reminds me of the atmosphere that I experienced yesterday when there was this beautiful sunset or something like that? You don't know why that's suddenly popping back into your head because all of those processes carrying that out are transparent to us. They are not being represented in the world model or the self model. So you've got the phenomenal experience, that which you do directly have access to consciously through conscious awareness, and you've got this transparency and this interface to the transparent things, and all of that, both the transparent and this phenomenal experience, are somehow taking place inside your organism. They're part of your brain, part of what your brain is doing to produce your mind. And every once in a while, this self model generates the pilot in your flight simulator, and it's not always there. The direct actual awareness of, oh, this is me, isn't always present. It's really just being generated whenever necessary to integrate things, to monitor, to remember explicitly, to predict things because you have plans, etc. Another thing you can ask about is, what are the potential different degrees of consciousness? Because, is consciousness just purely something humans have? Is it something AI could have? Is it something animals have? How about infants? There was a whole time when people thought that infants weren't conscious, couldn't experience pain, and so you could operate on them without using anesthetic. That's crazy, but there was that. So anyway, this is again based on Metzinger's approach. He has this notion of a minimal consciousness where at least you're generating a now. You have some concept of what this current moment is. And it's just that snapshot, just the now. And that there is global availability of some information. At a slightly higher level, I don't even know what has minimal consciousness of that kind. I don't know what to point to, because at the next level, differentiated consciousness, that's the first point where you actually get the dynamic evolving of that system, that the self-model and the content of the self-model and the content of your world model is changing over time, either because of something you're doing internally where your brain is providing information, or in external sensory data that's changing what's going on. There's some process that makes it evolve, and you can segment it out into, say, you've got vision and auditory and so forth. And you could imagine that there are some creatures that perhaps exist at that level of differentiated consciousness, but not beyond, because maybe they don't have a very strong self model that can actually produce an identification with that model? Possibly. I'm not exactly sure which ones I would put in that category. But then there's the level, subjective consciousness, where you have an actual explicit self model of some sort that you associate with. And there is an integration between that and other objects, like things outside in the world, goals, your own actions, and those become part of what you're representing as well. That's a slightly higher level of consciousness, something that is almost at the human level. And I think that many animals probably have this too. And then there's one more level, cognitive subjective consciousness. And this is the kind where not only can you make a virtual reality of what the world is like and what you're like right now, but for example, you can use it offline while dreaming or while planning. You have some future plans and you're trying to imagine what the world could be like and how could I get there, or you have different worlds in mind. And also, just the ability to at least grasp something about how information ended up in that self model. So you have a bit more explicit access to some of how did this come about. There's a bit more opacity. So you could have some representations of, oh, this is how I think, this is what logic is, or something like that. And that's really what human consciousness also contains. I think an important thing that we need to understand is that consciousness and how we experience the world isn't something where I'm tuned into what's going on right now. I am making judgments about things that really are. There is a lot of evidence that there's a time delay involved. There's such a thing called post-dictive events, which is where something that you do at a later time can influence something that actually happened and then change how your awareness about it appears. There's an experiment here, for instance, that was carried out by Chernovsky et al., where they had people observing two different stimuli, where either the first line is before the second or the second line is after the first. Then you show those stimuli in order, and what you end up with is a fused perception of them. But then you can do interesting things. So you can apply TMS, transcranial magnetic stimulation, somewhere along that line, not just when you're perceiving one of the two, but also a whole while after that. And you can see that it has an effect. I won't get into the details about what those effects are, but what it does show you is that even if you're applying TMS much later than when you were first processing that incoming stimulus, it still changes your awareness of what you saw. And it can change based on where you apply that TMS. So somehow what's ending up in our consciousness is a post-processed sort of post-hoc thing with maybe 350 milliseconds after that. There's, of course, Libet's work as well about decision-making, how the activity in the brain that represents a decision is already there long before you yourself can determine that you're aware of the decision-making. So that's really interesting because it kind of says that our conscious mind, our experience of ourselves at every moment is like a story that we keep putting together, where we're getting the gist out of something. And then we can do creative things, really interesting creative things. Like, for example, to me, it looks like everything's in color right now, but I have hardly any color receptors in my peripheral vision. So somewhere along the way there, I took that and I filled in a bunch of extra creative information. So part of the claim I'm making here, and good, I'm kind of on time, is that the way that our subjective experience appears to us, it's not necessarily a deeper thing. It's almost a more shallow thing. It's really the lack of information that determines what it's like. So the phenomenal structure is determined a lot by what we're missing, what we don't know about the world. So the amount of information, the content in our self model and in our world model is a limited piece of what's actually going on, not just in the world outside, but in our brains as well. And we become self-identified with the content that we do have, this limited amount of information. And that self-identification with that limited amount, that bounded information that we've got, is super important to trying to understand how come we can have this notion that there is this self and we're looking from the inside out. And I'll get into that in just a moment. So very important at the bottom here, experiential judgments are made based on the content universe of those models. can only be made based on the content of what we have available to us explicitly to awareness in that model, because that's where we make our own judgments to ourselves about our experience. All right. Some of you may have heard of the anthropic principle before. I'm not applying it in exactly that same way here. So the anthropic principle is one of the approaches to the problem of how is it that there is a universe in which we live, given that physics shows that it's so finely tuned that if you change some parameters, you instantly end up with a universe that can have no stars, or you never have anything that could bring forth life of the kind that we know, et cetera. So it seems to be a narrow band of possibilities. And then the idea is, well, as an observer in that universe, obviously, you can only be making these statements and thinking about it in a universe that brought about those kinds of observers. So it's an observation selection effect. I'm not going to get into that because I'm not trying to defend it or say how that's broken as an explanation or anything like it. I'm just using this notion of the anthropic principle here to think about this content in the self model and in the world model that you have. So it's the idea that there is a selection effect, an observer selection effect to how things appear. The range of observations that are possible are limited by the types of subsystems that produce observers. And this is where we get to TACT, the Transparent Anthropic Coordinate Transformation Model of Subjective Experience. So we begin here with a brain that has a whole bunch of processing going on of which we are not subjectively aware. We don't know what's going on. It's not explicitly accessible to us. It's transparent. But somewhere in there, there's a model that we have become accustomed to identifying with, ourself, my body, me, what I'm thinking. And now I'm going to make a judgment about my experience, or I'm going to try to express what I'm aware of. This is this knowledge that I have. And I make, first of all, I notice, oh, this must be me. This is what I know. And this is composed of this transparent source and the confirmed, opaque availability of information that is in the self model, where I'm absolutely sure this is what I know. So here I'm trying to make a judgment about that, and I say something like, oh wait, I skipped one. I say something like, cogito ergo sum. I think, therefore I am. You know, it's obvious. I'm right here. But if you take away all the transparent pieces, it seems like this. You've got your self model, and you make the statement, I think, therefore I am. What does that do? Well, here's the stuff that I know that exists. This must be me. The other things I'm not aware of, they're really not there. So then automatically, the stuff that you do have becomes your universe, and there's a center of gravity to that. It's like a coordinate system transformation that's happening, where it feels like that's where everything's coming from. So the anthropic principle of the sense of self is basically, well, how else would it feel if you have just that limited amount of information available? Where else could your center appear to be? So this gives you the illusion that consciousness has to be the root of everything, because that's, the thing that you have access to. When in reality, all the evidence shows that you require a whole bunch of stuff to process and do things to bring about consciousness. And if one little bit breaks, your consciousness changes or disappears. So it's clearly dependent on that. It's actually the other way around. And that's the observation selection effect, which makes it seem that the irreducible fact is the things that are in your self model, and that's where the basis is. That's the fundamental part. That's the part you cannot doubt. Everything else is kind of coming out of that, when that's not really what the evidence says. Now, a word about panpsychism, and it's really not a word about panpsychism, it's a word about terminology. I like to be very careful to use my words only in specific ways. So this thing that I was talking about, this coordinate transformation, the idea that you have information that's limited, and therefore you can always apply a coordinate transformation where you put a center there, and then you look at everything in reference to that center. You can do that for all kinds of systems. You could do that for a thermometer, for instance, where there's a part that receives the eventually has the number, okay, it's 30 degrees Celsius or whatever, and has no idea where that came from, has no idea about mercury and things like that. So does this mean that everything is a little bit conscious? Does it mean that consciousness is a fundamental thing for everything? Well, that's where I have no problem with that. And Lincoln was telling me about proto-panpsychism as a nice word to use for that. I don't mind the idea of thinking about it that way. I don't mind applying the same principles to other subsystems, but I like to keep it separate. I like to say, okay, this transformation is one aspect, one feature of what we consider human consciousness, human self-experience. And that's not necessarily the same kind of thing that a thermometer has, or a computer, or some other thing. So I'd like to keep those bits and pieces separate, putting together all the parts that you need for human consciousness, and then saying, that's the consciousness that I talk about in daily life. That's how I use the terminology. Because if I start applying it to all kinds of other things, what it does is it dilutes the conversation about the thing we were actually trying to study and understand. So I don't do that. Now, a question you could ask is, so we've been talking about how subjective experience emerges, how it can be there, and emerging is maybe even the wrong word. It's just the only thing that could be from the perspective of that system. So which part of the weirdness that Chalmers is talking about in his hard problem does it address? Because he has multiple things that he talks about there. And this really just addresses the question of how it can be that there even is such a thing as subjective experience. How do you make that flip from talking about how the brain produces all kinds of things and then talking about, oh, well, but this is the experience I have, and it's just there. How is there even a feeling? How are there raw feels? It talks about that. So this unavoidable perspective that's necessarily the result of the universe, of the content that's in that model. And to me, that's important because for whole brain emulation, it addresses questions like, well, if I feel like I'm over here right now, and something happens to me, and then you build me a new brain, how can I now be here? How did I get there? And that question doesn't really arise when you're talking about it as, okay, well, this is the necessary consequence of the content of that model. What it does not do, this does not address questions like, why does red feel a certain way? So the particulars of these qualia, for instance, in a particular context and a particular day. But nevertheless, because, can't help ourselves, we have to try to talk about everything. We can also dig a little bit into that one. So I like wondering about qualia, because when you talk about the traditional qualia, the way they're described, they're meant to be atomic and stable, unchanging. So they're kind of the units of consciousness in a sense. And red is often brought up as an example. But just thinking about red itself, for instance, it makes me think that it's not quite atomic at all. And it can't really be, because what does that mean for red to be atomic? Red, even when I think about red and I have a feeling about red, like just from a sunset or whatnot, or a rose, which, by the way, those are already different experiences of red. So red isn't quite stable, right? It depends on the particular day and what association comes up, and the feeling of red, the experience of red, that quality changes to me. But what's more is that just like anything else, like the dots on a page that we read that turn into words, that turn into prayers, for instance, they only have a meaning in a certain context. Meaning is always associated with context. The meaning of any activity in the brain, when you have an MRI image and you show, well, this is the area that lights up, the meaning of whatever's lighting up in there only exists in the context of an encoder and a decoder. The encoder is whatever got those bits to light up, and the decoder is what uses what's in there for something else. For example, an action. Say, oh my God, this is a beautiful sunset. Great, wonderful, beautiful red there. So keep in mind that it's always in a context. There are some other aspects that I won't get into here, but in any case, I strongly suspect that at least some of the traditional qualia that people talk about are not atomic or stable. So another point that came up, one of our journal club members, he felt like this was still not getting at what he means by this is my awareness when I look outside the window, the raw feels of it. Where does that come from? It seems so irreducible. And I don't really know the full answer to that because I don't have the explanation how all the bits work. We haven't yet deconstructed the neural circuitry to the point where you can follow everything all the way through and say, well, this is what ends up in your self model. That's why it feels that way. But there are a few bits of information that I take as kind of hints to where this is going. So in that model that you have, the knowledge just appears to be there without knowing where it came from. So it's not grounded in a further fact. It's kind of shallow because you don't have all the context, you don't have all that information. There were some calculations about how many bits we're actually aware of in any second, and it was pretty small. So it's pretty shallow, and it must appear to be at the center because of the boundedness of the information that's there. So you can kind of ask yourself, well, what could be more raw than an experience that's coming from something like that, that's so bounded and shallow? I'm still not quite sure that I like this explanation. I'm not perfectly happy with it, but I'm hoping we'll go somewhere with it. Quick word on the development or emergence of subjective experience and of our conscious selves, because as I mentioned, it's not obviously innate. An example would be, for instance, perhaps, again, just a hypothesis, maybe the moment where a toddler changes from saying, Sally wants the ball to I wants the ball is an indicator about when you have experienced your self model or your world model or a part or a subset of that in enough different contexts that you know which parts are stable and belong to you, and you've become accustomed to being in control of a part of it, and also, of course, learning language, symbols, which is really an important part of how consciousness operates, is in symbols. So perhaps that has something to do with it. I'm running out of time and I should rush through this bit. An important thing that we're getting to now is mechanisms. And I think it's important to talk a bit about the mechanism of the phenomenal now. Because an important piece of subjective experience is that you have some cohesive notion of what's going on at the moment, whatever that moment is. Brains have to generate their own internal time. They have to generate some notion of the present. And again, the process that gets you there is transparent. But there's some evidence about how this comes about. So for example, theta oscillations, theta rhythm in the brain is typically something that accompanies conscious awareness or conscious action. Theta is intrinsically linked to working memory. In working memory states, whenever you need to use your working memory, you also see theta. Consciousness is integrative. It has to use information about all sorts of different modalities. Working memory exists over the entire neocortex, integrating globally information coming from all over the place. Working memory is slow. It requires repetition. It requires a loop of activity that is separate from just the synaptic connectivity that allows very rapid ripples of activity through the brain. So this is the slow, the Kahneman slow and fast thinking. It's the slow part of it rather than the fast part where you're automatically figuring out that you should veer left because of that car that's coming on. So we have here the possibility of dual mechanisms that are really mechanistically separated, that are supporting different parts, subconscious and conscious operations. We've got our self-model with our memories and drives that are transparent. They're somehow producing a phenomenal now. And one way to do that is through working memory. Working memory I won't get into the details because I'm really running out of time, but for a while I was studying how short-term buffers actually appear based on the so-called pyramidal neurons that are all over our neocortex that have a thing called ADP, which allows them to reactivate if they fired once, even without any further input from the outside. So as long as theta is present, they can reactivate for a period of time, and that's a buffer that doesn't even depend on synapses, which means that you can use that buffer to strengthen synapses and learn new memories. So that's why working memory is super important. It's also thereby a completely different mechanism. It doesn't work like just the regular synaptic connectivity in the brain. So you've got two different axes. You've got your long-term memory using one type of mechanism, working memory using a different one. And then, well, this is just an example of what that kind of a short-term buffer looks like. It keeps things in an order, so you maintain the order of what happened. Well, when you have this, you've got these dual modes. You've got subconscious transparent processing happening, very rapid ripples throughout the brain in one part of theta. And then when theta is high, when it's making it more likely for neurons to reactivate by themselves due to this ADP, during that phase, you've got your ability to keep your working memory going. So you've got two different mechanisms that can operate in the same neurons repeatedly every theta cycle sometimes for quick retrieval, sometimes for this reactivation in working memory. So there's a mechanism that can support both different types of processes, all of which, of course, is transparent to our awareness. And yeah, I am so running out. I better hurry up. So I will get on to the next part. I wanted to say just a few things about illusions that accompany our sense of experience, our experience and awareness. And what I mainly wanted to point out is that, say, if you're thinking about your own introspection, when you're using that to determine your experience and what subjective experience is like, be careful because, for example, physics is already very much used to not relying on common sense explanations for everything because common sense can lead you astray. It's based on what you experience every day and therefore what seems normal. So for instance, in physics, Newtonian perception is what we would intuitively expect, but really everything is relativistic. Dan Barker came up with a nice word for this sort of fallacy to rely on this intuition, and that's contradiction, that leads you to sometimes invert the arrow of causation. The error in this case, for instance, would be subjective experience is direct. It's what I'm experiencing. It's what I know. It's tuned into the deeper reality when, of course, reality is really what's informing this brain thing that you've got. And most sources aren't really accessible to introspection. Active awareness takes effort, so you have to shift around your attention. You can only keep a few things in attention. You lose other things if you're shifting your attention. So you can notice that you will never really be aware of a lot. It's very shallow. Also, the stream of consciousness, I don't know how many of you already know that this is very hotly debated, whether there's even a stream of consciousness. Susan Blackmore is great at pointing out how this is very likely an illusion of there being a continuous stream of consciousness because it is a sampling error. Every time you ask yourself, am I aware? The answer is yes, I'm aware. So it doesn't matter how much time is going by and whether your pilot, your little self was absent, was not being generated. The next time you ask for it, turns on again, answers yes. So all the yeses, put it all together, your samples are telling you you've got a continuous stream of consciousness. Okay, so this is really, we're at the end now. Great, perfect timing. I just want to present a few threads of evidence for this TACT approach. Manipulating the brain can disturb your world and self models. There are lots of different sources of evidence for that. The origins of your knowledge are transparent. I think that's pretty obvious. Only a very limited amount of information is actually available to you consciously, so the scope and precision is very limited. Subjective experience is a virtual representation. Effort is required to become aware of something, so it's a specific process you have to turn on, in a way. Our scope of attention is highly limited and needs to shift around. There are post-dictive events, so our awareness is post-hoc. It's not in the moment, it's not immediate, it's not exactly what's happening right now, the state of the universe. Stream of consciousness is a sample-based illusion. Qualia may not be fully atomic or stable, at least not the traditional ones that are often talked about. We can still see if there are certain ones that we could say are stable and atomic. Subjective experience is really a process. I mean, everything I've talked about now shows you this was all process-based. It's not a single state, right? So it's best to always think about experiences as a process rather than the state I'm in right now. It's a process. Selfhood is developmentally learned, not fully innate. And we have these dual separable mechanisms that can support different types of processing, subconscious and conscious operations. And then finally, I want to make sure that I thank Ken Hayworth, who put in a lot of work helping me with this, as well as the rest of the people in our Consciousness and Subjective Experience Journal Club, everyone at the Carbon Copies Foundation and Brain Preservation Foundation. And of course, I'd love to thank all of you for inviting me here and for paying attention. Thanks so much.
Okay. This mic is working. If you want to come to this one, and he's getting this one working, or I can come and hand to you if you have a question. Any questions? We got about 9 minutes or so for questions. Okay.
Okay, both the mics are working. We're just waiting on you in the back there. Can you hear us? Check, check, check.
Check, check, check.
Oh, that one's definitely on. Oh, this. Hello, hello, hello.
It's working.
Yeah. Okay.
I was wondering if you could. I'll just take this. There we go. Thank you. I was wondering if you could. You mentioned this concept of we can't perceive things. We have a certain pace of perception, and we can't perceive things that are moving more slowly as well as moving quite a lot faster. Can you explain a little bit more about that in the context of there's some USC physicist who has coined the term evolutionary headsets, that we're wearing these headsets that kind of collapse fundamental reality into something that we can understand given our processing speed. I was just wondering if you could talk a little bit about that time distortion.
The virtual headset, by the way, that totally fits right in with, we're living in a virtual reality in a sense. There's no real mystery about the sort of limited time windows that we can operate in. Neurons can only fire at a certain maximum rate. They cannot activate more quickly. Subthreshold activity that is not based on this firing rate that we can achieve is hardly involved in most processing in mammalian brains, except perhaps there is some in auditory perception to be able to distinguish very precise, spatial localization. You have to do some really fast calculations, and there may be some dendritic operations in there. But even then, neurons will not give you more than, say, 1,000 spikes per second. And that's for the really fast ones, of which there are few. Most will typically, on average, fire 2 times per second to 10, and then when they're really busy, 100. And that can tell you that there's a maximum sampling frequency for everything that's arriving into our brain. And you would think maybe you can just stagger that by having different neurons sample at different offsets. But that doesn't really work because most of the activity in the brain is regulated by rhythmic oscillations, so that neurons will only fire at certain intervals, certain phases of rhythms. And then there's a bunch of interneurons, these recurrent inhibitory networks that shut down all activity between every of those cycles. So it's almost like the brain is clocked most of the time, like a digital computer. And it's not weird to think that the brain would do that, because why are computers even digital? Why don't we use analog computers? Well, the main reason is for precision and reliability. You want one part of the computer to be able to communicate with the other. You need to know when you're expecting new input and whether it's a 1 or a 0. The same way you've got different regions of the brain, they want to communicate, and you don't want to accidentally think that, a tiger is your grandmother or something. So robustness and reliability is very important. And for that, the brain applies a whole bunch of constraints that don't allow neurons to basically take advantage of their whole analog range, but instead to only fire at certain times, to only mean something when they fire together as large populations, and various other things that you put in as little extra reliability, safety issues, safety mechanisms. And all of that, in the end, it kind of constrains how the brain can operate. And that's where you get these maximum firing rates and this sampling at specific offsets. And even that phenomenal now window, the 350 milliseconds, it's interesting that what they found was that although the input processing can happen at almost any time, the sort of phenomenal now moment almost shifts as a kind of digital interval, sort of blip. This is the phenomenal now the next one, now the next one. It's as if you're replacing in a discrete fashion what your experience of the now is. So that gives you, your upper rate, your cutoff there. And the lower rate, this not being able to tune into really long things very well, that's not really a brain mechanisms thing. That's more of, I guess it is a little bit because our working memory buffer is limited, but it's not a huge limitation. The biggest limit is just that our lives happen at a certain pace, and slower things like trees growing is not something that we just normally are aware of. Oh, this is growing right now. We might notice, oh, this is the tree now, this is the tree later, but we're not really aware of it's growing because it's too slow. And the same way, we can't really deal with plans or things that go way beyond our lifespans because we're just not built for that. But mostly it's just the upper limit that's the thing that I'm most curious about is what would the world be like if you could actually experience it the way that, not even a computer there at gigahertz, but if it was just, 100 times faster, what would that be like?
Let's just see really quick. We got 3 more questions, I think. So let's just, is anybody else besides that? Let's try to keep the questions brief and limit it to that, but we'll do these. Caleb and Jordan and Brent.
Yeah, so thanks for their presentation. I was curious, in your TACT model, what would you see, like we went through kind of a meditation practice earlier, how do you see meditation impacting things in that model, like specifically the opaqueness and transparency of some of those things, and how would that actually change what's going on in the brain? Thanks.
So the honest answer is I haven't really looked at it. So I can't pretend that I have a good model for that or really understanding. I have practiced meditation myself. I've also taken psychedelics, and I'm especially fond of ayahuasca, actually. So I know that there are different states that you can achieve in consciousness, and I assume that through meditation you can also get there, but I don't know if the mechanisms are in any way related, because in psychedelics often it's shutting down a lot of what's going on in the brain. It's really calming down brain activity, and maybe this is the case in meditation too. I don't know if anyone can enlighten me on that, because I just don't know. So I think when you have changes in your conscious perception, in what your consciousness is able to process, and the awareness that you can therefore have based on the content that's ending up in your self-model and world model, it can be because the content changes, the amount of the type of content or what's being pre-processed, how. So I can't give any specific, I don't have a particular idea of, oh, this is why it feels this way or something like that. I just don't know. I haven't studied it yet. I've only just gotten into this part of our research, and this is like less than 1 out of my 7 days typically that I would spend on that. Sorry. Maybe in a few years we can talk about that too.
You hear me okay?
Yeah.
Okay, great. So 2 parts to this. The first part is, using your TACT model, can you speculate or give an opinion on where LLMs are at this point in terms of the development or degree of consciousness? So using your TACT model, can you speculate or give your opinion on where LLMs currently stand in terms of your degrees of consciousness? And obviously, with all artificial intelligence, the big question, the big problem is alignment. If this represents a stage in cognitive or conscious development, where LLMs and things like are at this point, how, and if it's like their dream time, where things are just going really fast right now, which is partly why they hallucinate, is maybe a way that we solve the alignment problem by getting artificial intelligence to slow down, to integrate, to develop a global kind of subjective experience. And is that how maybe we can approach getting them to love us and want us to be around?
Okay. Those are a lot of very different questions, because I don't see them wanting us to be around. I don't know if that necessarily connects to them loving us. That might be one way for them to want us to be around. But there are other ways, maybe, right, that have nothing to do with them having a certain desire or emotions, in a sense. But getting back to this, where are LLMs actually at? Which we actually thought about this during our sessions as well. We were trying to figure out where do they fit in on this hierarchy right now. But you notice that, for instance, under subjective consciousness there, it does require that you have a phenomenal self model. And I am not an AI researcher, just like I'm not a lawyer and not a philosopher, etc. So I don't really know exactly what the best LLM models currently have, besides their deep networks, their transformer nets. Do they have in there something that you would define as a world model and a self model, besides just a huge plethora of information that they then associate in a certain way to predict the next token? Token prediction isn't necessarily the same thing as having a model of how the world works, but these reasoning models that now exist as well, perhaps they do have something explicit like that that's been added in. I'm just not sure, because I'm not an AI researcher. But if they don't have something like a self model, something that they identify with and that is separate, operating separately, that has only access to the information in that self model and not to everything else, so if there's that transparency, so that you bring about, through necessity, that the reference point is in the center of that self model, giving you a subjective experience, then I would not expect them to have that based on this model. But yeah, it really depends on what's actually going on in LLMs, and I'm not an expert. Yeah, sorry. And is there a part I left out that was really important? Other parts of your question?
Oh, just the different caps of the function. That's that was maybe you need to slow it down to
So that is actually, yeah, that's super relevant. I've thought this several times about how LLMs currently work, and how the big difference between AI and the human brain is that AI often has one global algorithm that it's applying to everything, whereas we have different systems that are operating in different ways, have completely different mechanisms for different purposes. So there's certainly a difference there, the homogeneity versus heterogeneity of the system. And I believe that something like having a buffer, that you can then create a phenomenal now out of, is an important aspect for a agentic, or maybe even aware type of model. So I think you would have to have these separate streams that work differently. You've got the pure auto-associative retrieval, and then you've got your system that is maintaining the now and updating the now and has a model of the self and the world in the now that's doing that. And then, of course, you can talk to the AI alignment people and wonder whether you should build something like that or not. So, yeah.
Yeah, is a redness quality a property of something or some process in the brain?
Sorry, can you say it again?
Is a redness quality a quality of something or some process in the brain? What is a redness quality? Is it a quality of what?
Good question. When I think about red as a qualia, I think of it as attempting to be something atomic, so a concept, something that is disconnected from directly being about, say, the color itself, or about the perception of the color, or the sensation of the color, more about the context and associations. So the qualia, that's why I say it's not atomic, or it can't operate on its own, because what it is different depending on the encoding that gets it there, that gets you to have that qualia merge, and the decoding of what it's then in the context of. So I have a really hard time with qualia as a whole, because whenever I just think about it as a system, it's very hard for me to pinpoint the point where I say, okay, so now this is the part where we have this bit active that is the representation of that particular qualia. For me, that's very hard. Maybe. I haven't decided yet. I have not decided. I need to have more. Maybe what I need is a good reason to determine that they exist. Because why should I care about qualia? Sorry?
So you think it's a possibility that redness quality doesn't even exist?
I mean, it's a word that we're ascribing to something. It's supposed to mean something. So tell me what it's supposed to mean, and then let's find where it is, where you could find something that matches those features, like as, for example, atomic and stable. It could be all kinds of things that are stable, but what's atomic? So we have to think about that very carefully. What makes it atomic? Further, you can't, yeah. Yeah, sure. Okay. But that's great. I'm at a disadvantage because I really am not a philosopher. So I am an amateur in all this stuff, right? So, yeah.
Thank you.